I'm going to go ahead and get started. We're a little low on time. I think we're going to go over and crowd into lunch a little bit. I got a ton of information. I'm already cut some stuff out. I realize I've lied to you in the description. I'm not going to talk about Puppet Chef, that kind of DevOps stuff. Even if I was, it was going to be about a sentence worth anyway. So everything else, all those little buzzwords, I think that we're going to hit today. My name is Chris Wells. I'm a developer at Redfin Solutions. We're a company based in Maine, in Portland, Maine. The popular Portland, as we like to call it. The one that everyone's heard of when I say I'm from Portland. I'm going to talk to you a little bit about performance today on Drupal sites, going all the way from sort of where we start, you know, with your maybe just your blog site you got set up in Drupal, and maybe your blog takes off all the way to the level of whitehouse.gov, and there's different things that we can do at each step of the way. So the way that I'm going to sort of structure the presentations, we're going to start small with the setup you typically start with. We're going to branch out into what are the optimizations we can make to that setup, and then what are some additional things we can add in to help with specific types of problems that we encounter. Everything that I'm going to talk about comes out of this book. This is, I don't purport to be the expert on performance. I read this book, and this is probably one of the, oh no, Clark. I think it's touchy. I think the connections are dodgy. I'm going to stay here and not touch much. So, this is probably the best technical book I've ever read. For what that's worth, this was astounding. If you're interested in these topics, get this book. They're not paying me to plug this book. It's just that good. So everything that I'm going to do is glance over the topics they cover and sort of what they're used for. Get the book. It'll actually show you how to set this stuff up and go into more depth about why these configuration settings matter and why you should look at them. All I'm going to do is tell you, go look at these ones that are important. So a quick refresher. What we need to do, much like Larry was just speaking about, we need to think of this whole process in terms of how the web actually works, HTTP, requests, and responses. And it all starts at your browser. So your browser is going to make a request to a URL, and that request is going to travel all over the internet's tubes and through all the tubes, and it's eventually going to come out on the other side somewhere. And it's going to hit a stack of software and hardware that serves this request. And the first thing it's going to hit physical machine after it gets through the networking layer, and it's going to hit the operating system, and the operating system is going to hand this request off to something that cares about it, your web server. And then your web server is actually going to, these are in kind of the wrong order, but they make the acronym really cute, so I kept them in acronym order. But it really then hits your application, which is written in a particular language. And that language invokes your application. Your application might talk to a database, get some data back in. At least with Drupal, this is how this largely works. And then we have to do the whole entire return trip, and we have to go back up through the stack and back through the tubes and back down to the browser. The browser now gets a response, an initial HTML page. And of course, this could be a mobile device that's parsing JSON, or it could be HTML. And I'm focused a little bit more on pages for websites, but a lot of this stuff still translates. Do I touch it? All right. Eventually, it comes back. I'm just going to keep talking.
Stop walking back and forth.
See what happens. I do. I'm going to lean like this. Is that going to freak everyone out? Yeah. And then my browser gets this response. And what does it do with it? It probably makes 2, 3, 5, 50 more requests for more of the things. And we need to take time and take the response and interpret it there on the browser side. So this is how this whole thing works, right? And we typically call this stack the LAMP stack because it's a cute acronym. Linux, Apache, MySQL, and PHP. That's the typical stack that we're going to run Drupal on. You can run Drupal on other stacks. You can run it on a WIMP stack. My business partner was responsible for a WIMP stack implementation of Drupal that he had the privilege of hating for 3 years. And he finally convinced them to switch. We've had some other clients that we're in the process of converting and having them make the switch. A lot of these are people who just really come from Windows shops. And all this stuff, I'm going to frame it in terms of LAMP, but they all have parallel concepts in IIS or whatever it is. So, this is the best slide in the entire thing. What could possibly go wrong? There's almost no complexity in this system whatsoever, right? So, somewhere on this chain, things go wrong when we talk about performance. Something, typically, we say, gets slow, okay? So before you run into these problems, and unfortunately a lot of times when we start worrying about performance, it's when we're in crisis mode. All of a sudden, something's too slow to be acceptable. But here's what you should do today if you don't have performance problems. You need to establish a baseline. Even if you're in crisis mode, you're going to do this in a very minimal way. You need to get your basic readings. You need to get averages of what are page response times, how long does it take to serve this request start to finish, how much memory is being used to serve requests, how big are my Apache processes, how much memory are they taking up. And this is even the most important thing. You need to identify what an improvement is, because performance projects can largely be a rabbit hole. You can optimize and optimize and optimize, and you can always getting down. But when are you done? You can never be done sometimes. So you need to define, when are we done? So if that's, I'm going to take the front page load time from 7 seconds down to 5 seconds.
It seems like when you're moving the remote around, some of it's having issues.
Let me see if I don't do it. I'm going to have to stop over here. So anyway, only then do we really begin the diagnosis. What we're actually after, and how do we find out what the actual problem is. And this is when we get to play doctor. This is now where we start the process. And like any good doctor, we have tools that we use to get this. So what are these tools? How do we actually start the diagnosis? Your number one tool to get started with is your browser's debugger console that comes with any modern browser that you're using today. IE even has it. When you press F12, there's Firebug, there's built-in consoles and inspectors, and there's also Google Analytics. Is anyone not running Google Analytics or have not heard of Google Analytics? Awesome, you're in the right room. So Google Analytics gives you baseline page performance requests. There's also Google PageSpeed and Yahoo's YSlow. These give you the sort of holistic perspective from the client side, making a request, all the way to when the client thinks the request is done. So that full life cycle. There's also real user monitoring. This is a program called New Relic that we use. It's awesome. It also gives you the whole life cycle of the request, including on the server side. So this is what your console ultimately looks like. The people who run Drupal.org know what they're doing. So you can see that this request, it kind of starts over here, and it ends right around something like 840 milliseconds. That's pretty amazing. In my world, none of my sites do that really that well. So these are guys who know what's up, but we're going to come back and we're going to look at this particular thing in just a minute. That's an important aspect when you start your diagnosis. I also want to show you, oops, not down. This is what New Relic looks like. So this is our Redfin Solutions. This site is so minimal that we've pulled it off. This is the 600 millisecond marker. So our longest request over a 3-hour time period was about 600 milliseconds. And you can actually see how it breaks it down. So this actually can show you all the way through how long it took to render the DOM. So it injects JavaScript basically that will track it on the user side, and also it does profiling as a PHP module on the PHP side. So it gives you the full request. This happens to be filtered to only show basically server side. So here I'm spending most of my time in PHP, not in the database. Here, there's a little bit more of a gap in database, and this little green thing is web external. So that's that's us making Drupal HTTP requests in Drupal 7. So that's all that time. So those are your tools, and so far we're still kind of on the client side. So what you want to do is you want to identify where in this path of the response are we failing. And one of the easiest ways to do that is you're going to look at the time to first byte. So that's the time that it takes for your server to start spitting back data. So that means if your time to first byte is very long, that probably means that your server is taking a long time to generate the response back to you. And the time to first byte is the light blue region of that very first request when you look at it. So if we were looking at, this is called a waterfall, you see how they all kind of, and it represents all the requests that are being made for all the static assets, the JavaScript, the CSS, the static images, each request. So if this whole thing were shifted way over here, then we could conclude that most of the time is really being crunched on the server side. So it's database calls or PHP is slow or something like that. So on the server side, if you don't have something like New Relic, which is great but costs money, you've also got some tools on the server side that will help you profile the performance on your side. And that's the Devel module is part one. So these are kind of in order of complexity of how easy they are to enable. So the Devel module, it's a module, you enable it, you turn on some settings, it'll show you page timings, how long it took to generate the page. It will show you how much memory is consumed by the request, and it will show you database query logs and how long the queries took to run on the database side. Xdebug, a lot of people, I mentioned it being just a little bit harder because a lot of people already have it set up as part of their dev environment. Xdebug is a step debugger for PHP, so it lets you go through your PHP code one line at a time, look at variables and values, and it has a profiler built in that works with Devel. XHProf is kind of a, I like it, I think it's a great tool. It was, I think, built by Facebook and then open source, and it's a profiler for PHP that says, this function call in PHP took a long time. Sometimes that function call might be DB query. It might indicate that it's actually a slow query. Or in a performance project that we had to do, we found that, and we'll get into this for writing abysmal Drupal code, their request was dependent on a third-party web service returning a response before it returned a response. So they said, hey, this main checkout page where we generate money and people buy things, it takes like 35 seconds to load. And with XHProf, I was able to find that it was a call that went out and shortened the URL to some element on the page. And so they were dying on cache, only on cache misses for that page. And that's why XHProf showed me that that's what it was. So client-side optimizations are really about, if our time to first byte is low, and it's just taking a really long time to get that full, complete page load, then we talk about client-side optimizations. And there's two primary ways to optimize the client side. You optimize all the requests you're making by either making fewer of them or make them take less time. So by making fewer, this is like JavaScript and CSS aggregation. The aggregation is about glomming all the files together so that you make one request for a CSS file and get them all glommed together. That's a little bit different than a way that we could make CSS and JS smaller itself. The actual file size of that glom can be smaller by using compression, like gzip compression on your server, or using minification. So if you ever download a jQuery library or plugin and there's a .min.js version, that's the version you should use in production. It takes all the variable names down from 13 characters or whatever they're called that developers like to 1 character names. So that when that download happens on mobile or wherever it happens, it takes less time. And of course, making sure your JPEGs and your images are all compressed and web optimized is part of that process as well. If you're serving responsive, you can actually, now in Drupal 8 and with some of these other modules, you can serve smaller images based on the device capabilities. So you can actually say, well, if you're on desktop, it's okay. Send them like a 200K image, but give them like a 100K image if they're on mobile. Something like that. You can also optimize your markup. Let's kill divs. Drupal's really good at giving us about 400 classes that we can use, but we might not use them all. There's a lot of tools in Contrib. If you hear of a guy named Sam Richard, or his name is Snugug on all of the interwebs, he's all about the lean markup. He's a diehard. He likes, he thinks Drupal shouldn't ship with CSS at all, so that you can write it all yourself. I don't know if I'm quite that diehard, but lean markup, think of that guy. I really like what he's interested in. SPOFs are single points of failure. We see this. This is kind of like that situation I described before where the server was depending on an external web request to come back and it was timing out. You can do this client side too. We all do this with like share this and add this and Facebook likes, and we embed JavaScript. And if you embed synchronous JavaScript, then that means, hey, until I get back this response from Facebook.com, I'm not going to continue painting the page. I'm just going to wait and show the user a white screen. You've got to put all your JavaScript embeds, use the asynchronous code. Usually when you're on the site and they're giving you embed code, they'll tell you which it is. So you want the asynchronous code. There's a tool called Spofomatic, which will show you if you have SPOFs. It basically blocks all your external requests for those external sites. So your site, if you have a SPOF, if you have synchronous code, it'll show it to you by you go to a website. So I left that module on once and went to some other site. I was like, why can't I get this site to load? It works for everyone else. So be careful when you're using the Spofomatic plugin. And keep your libraries updated. These libraries, jQuery, jQuery UI, there's modules to do it, jQuery update, they keep it up to date with the latest versions. A lot of these libraries have performance improvements baked into them, and we want to use them. The other thing to think about is the actual network layer. We're not going to talk too much about it, but don't forget that it exists. Hardware fails. Routers fail. We had one client who had a significant performance problem, and we couldn't tell why, but we knew that requesting the site on their LAN was lightning fast. So it wasn't on PHP side, it wasn't database queries, it was lightning. What was it? They had a multi-homed setup coming into their office. They had a 2 megabit connection, and they had a 50 megabit connection. Guess which one was serving their website? Oops. Yeah, network. So don't forget about it. We're not going to talk too much about it beyond that. There's also 2 ways to run Apache. You can run it using mod PHP, or you can run it using fast CGI. Mod PHP is generally preferred by the authors of the book because they're usually got some other layer that mitigates this other problem. So the main difference is that, my understanding is that PHP is loaded on every request into the Apache web server. So even if Apache is going to serve you an image, a JPEG file, we're going to load PHP in memory to do it. Now, it's also really great for PHP requests, because PHP is in memory when we're actually trying to generate stuff with PHP, so that's actually kind of great. Fast CGI does it a little bit the other way at the expense of more overhead for PHP requests. So instead, it gets a request, and then only if it's a PHP request does it shell out and load full PHP. So with Fast CGI and you got a JPEG image, it just gives you the JPEG image back. So you have to look at how you're serving these different types of images, different types of requests that come into your server, and what percentage of them are real PHP requests. As a general rule, mod PHP is faster for serving PHP requests, and the general recommendation is to serve your static assets with something else, so that your PHP requests are really lightweight. And there's a couple of ways that you can configure that. Config settings is another area that people frequently mess up, and I'm making a blanket statement that people frequently mess this up because I mess this up. So I don't know if I really am the general use case. But here's how it works. Essentially, Apache opens up slots, a bunch of different tubes for no better analogy. And every request that comes into the server, whether it be for CSS or JS or whatever the request is that gets to Apache, is going to be filled by one of those slots. So the 2 that are most important here are max clients and potentially max requests per child. Max clients is the max number of slots that will ever sort of be created. It's not necessarily true. Server limit is actually the hard value. But max clients is how many tubes do you have? But you need to just do like, well, I want to serve 1,000 requests, so I'm going to set max clients at 1,000. Your server might not actually be able to do that. So what you need to do is you need to actually look at your res column. Run top on your server while your machine's running. Look at the res column and see how much memory is being used by your Apache processes on average. If it's 65 megabytes on average, not uncommon, and you have 3 gigs of RAM on your machine, you can kind of do that division and figure out what your max clients needs to be. so that your server doesn't grind to a halt. The alternative is, okay, I've got 1,000. Here's what's happening. All these requests come in. They're all being fulfilled, but I'm out of physical RAM, so what am I going to do as a machine? Swap. I'm going to swap to disk. I'm going to take some RAM out of here, and I'm going to put it on the disk, and then I'm going to put some stuff on the disk and put it in RAM. And when I go back and forth like this is called thrashing. And you can thrash yourself to death by letting processes consume too much memory. So that's why you've got to tweak that max client. Max requests per child are how many times can this pipe serve a request before I throw the pipe away and give it a new, fresh, shiny pipe. Okay? And this really is there to sort of protect you from memory leaks. Who's ever used a partially maybe shady contrib module? Right? Maybe shady. Might have a memory leak. That basically means, hey, I'm going to go and I'm going to consume some memory, and then I'm not going to let it all go. I'm just going to leave, like, I don't know, 2 megabytes sitting there on the table. But every time this request comes in, now there's 4 megabytes of unused memory, on-free memory, right? And it leaks, it gets bigger and bigger and bigger, and all of a sudden you've got one of your Apache processes using 156 megs of memory. What's going on? So, what we can do is set a maximum number of requests before we throw that away and start a new one fresh with that sort of minimal amount of memory that gets used on average. So that's what max requests per child does.
What's a reasonable level for that, for assuming a well-behaved system?
The recommendation of the book is kind of like 2,000, 4,000. I think 4,000, they said in the book, that it's starting. I had a site that had a memory leak that was kind of happening to it, and I dialed that down to like 100 because we were actually, at certain points, like following Apache, it was having issues with that. So, I tend to go a little bit lower, but I think it's right off. 4,000 is starting. Keep alive is another piece of the puzzle. So that says, the request comes into the pipe, and the pipe says, oh, I'm not going to let anyone else use this pipe, because I think you're probably going to ask for some static assets back again. So I'm just going to wait for just you. And I'm going to keep this connection alive for you to make another request. As a general rule, implement Keep Alive somewhere else. Keep Alive, the implementation in Apache isn't awesome, but a lot of these Google PageSpeed tools, if you don't have it enabled, that's one of the things they're going to give you like an F grade on. You don't have Keep Alive enabled. There are better ways to handle Keep Alive, and the recommendation is to kind of use Varnish, because it does Keep Alive really well, and then your Apache is just there to serve your PHP request. So we'll get into that. Okay. MySQL, I got 3 slides on MySQL. There's a lot to optimize here, and I'll probably blow through this a little bit. So there's MySQL, there's MariaDB, and there's Percona Server. And I'm going to do my best not to speak out of turn because there's an Oracle person here. Oracle. So Oracle MySQL is the de facto standard. This is what's been around forever. This is tried and true. This is the big name player here. MariaDB was created by one of the principals of the MySQL project, Monty Wilder,
Virginia.
I say Monty. Yeah, so Monty. And he forked it. He forked MySQL and started MariaDB. It's a drop-in replacement for MySQL, and it originally started for some optimizations and performance reliability improvements, particularly, if I'm recalling this correctly from the book, in the MyISAM storage engine, MyISAM, one of the ways that MySQL actually stores data on the disk. What the book kind of says is, well, MariaDB and MySQL, you could go with Maria if you had those specific needs, but a lot of this code is getting shared back, and it ends up in, a lot of it that's really important, ends up in Oracle MySQL. So it's your call. If you like some of the things that MariaDB has to offer, it's probably going to be a little bit out on the cutting edge, but your call. Percona Server, the book says, if you don't know that you need something from Percona Server, you don't need something from Percona Server, so don't worry about it. So I don't know too much about it, which means I guess I don't need it either. So there's a few settings in MySQL config. I really want this to work. I'll touch on a few of them. Max connections. This is the maximum number of connections open to the MySQL database. Generally, PHP requests are going to open a connection and use it for the duration of the request. So what this means is if you have 60 max clients, should we have 60 max connections? So if the only thing using your database is Apache, I've got 60 max clients and I've got 60 max connections in MySQL. These things match up perfectly. Where this falls apart is if all 60 of those requests end up blocking, now I've got no way to get in and kill them. So max clients plus 1 is a good recommendation for your max connections in MySQL, if nothing else is using that MySQL.
One thing to note about that, even if it's hitting that threshold, there's always allowed one extra connection by the root so that you can get in there and manipulate the server configuration if it's at the threshold and you're not locked out. Additionally, a lot of times when you're hitting the threshold, it's mainly because of a poorly programmed application. Usually,
Right.
you know, it opens a connection, it's about concurrent connections, and a lot of times you don't really have to set it that high.
Yeah, so that's the so why this spawns is because a lot of people see too many connections, so they go in and they up the number of connections. When really the problem is that your application is using multiple connections in one request. Your application shouldn't do that.
If I can add a comment as well, there's a historical problem here where Apache's default was 150 and MySQL's default was 100. So MySQL's new default is 151.
Oh
So
yeah,
it should be less of a problem.
yeah. And I haven't run into this. It's been kind of a bunch of years since I ran into this. But when you get into tuning it, you have to know what you're after. The query cache size is the other one I want to call attention to. So they basically said we can write a whole new book on MySQL query cache. The long and the short of it is you can use the query cache or not use it. In general, the recommendation is yes, use it. But if your query cache is too big, when it invalidates the cache, you end up doing too much overhead to rework the cache, then you're getting in gains. So another one of these, like, set it at 60 megs and start there and see how it goes. This is kind of the recommendation from the book.
Last time I checked, MySQL didn't use the query cache for prepared statements, which is all Drupal uses. So I'm not sure if the query cache actually buys you much with Drupal 7 later.
I can answer that in 2 parts.
Okay.
Query cache now supports prepared statements,
Aha.
but query cache is disabled by default in MySQL 5.6.
And it's recommended
And it's recommended in most
disabled by
cases, too.
Percona and
Most
some of
versions
the
of
other
default,
people.
it was disabled by default, and I got such a tremendous boost when I found that and enabled it.
Okay, so it is actually worth using now. With
No. No, it's still not. So the problem is that the query cache sets a global lock. And global locks, to be able to do that, reduce scaling on multi-core machines. So if we were on, like, you know, a laptop or something like that and it had one CPU, you know, great thing. But when we're running with hardware with 4 or 8 cores, it's actually quite bad. So this is a question maybe for MySQL engineering, but the best case actually for the query cache is if you do no optimization at all, because it can hide that very well. By you not adding indexes, it just stores results. But for a system that's had a little bit of tuning, a lot of people disable query cache. It's a very common optimization step. So there are still cases where it's useful, so it's so hard to get generic advice, but the default is now it's off.
We were in the VM, so it was hiding. Didn't have a core, just rusted.
So the tools you can use for managing and monitoring these settings and see if you need to increase your query cache size, for example, or change your buffer size, or see if your heap usage is up at 100%, these are the tools that are going to kind of give them to you. There's the Percona toolkit, the OpenArc kit, and MySQL report. These are the ones covered by the book. MySQL is probably my least strong, like, not a DBA kind of guy personally, but these tools are ones that you should look at about getting your baselines and your performance stats from MySQL. And like I said, MariaDB is a drop-in replacement, so these tools should work with Maria all the same.
It might be worth noting that a lot of the Linux distributions appear to be moving over in their next versions to Maria.
There are a lot, yeah, I think Debian is using
They're all
Maria.
switching over.
Drupal.org has running Maria for several years.
Yeah,
Drupal.org is running Maria.
if I can maybe answer to that point as well, sorry to be that Oracle guy. Ubuntu is using MySQL 5.6. Red Hat and CentOS, they're a little bit of a special case because we're a competitor with Red Hat, so it's not the easiest relationship. Debian is allowing you to choose which one you want to use.
Okay.
Yeah, that's
So- OpenCC is using MariaDB, yeah.
So your call. Go look at them both. That's my point. Go look at them both and see which one works for you. So when you're talking about optimizing SQL queries, the two biggest things that you want to look at are indexes and joins. Most of the time when you're writing queries, you're really writing them through views. So I want to talk a little bit about views pitfalls that we hit a lot. And basically, if you're using, and again, I'm spitting this out from the book, so my understanding is that if you're writing like a multi-column index, it creates a B tree. So it takes all the values of column A and matches them up to all the values, each one to all the values of column B. So if you're indexing by column A, comma, column B, but frequently you're actually filtering by only column B, you can't use that index because it doesn't come first in your multi-column index because it has no way to get to it through the tree. So that's just an important thing to keep in mind. A lot of times just indexing on the field that you're using as a where. We saw that in a Drupal 6 site with something trying to pull up a file download report and simply adding an index to the file name because it was querying by file name really just sped it up a lot. But when you get into multi-column indexes, you need to look at that. Joins are the other thing in MySQL that are basically inner joins are a lot faster than outer joins, like a left join. That means when I link this table up to this table, an inner join means how they join has to exist. An outer join, or like a left join, would mean this left table, if it doesn't have an entry in the right table, just fill in null values for the fields that I'm pulling in there. Outer joins are slower. You want inner joins. And where this starts to translate into views is when you have a relationship in a view. So you have your base table like node, but you want to pull in fields off the author. Require that relationship means it's going to use an inner join. So the time when you would not want to require that relationship is you have nodes that don't have an author. And I'll give you a hint, there's always an author for nodes because even if it's authored by Anonymous, they have an entry in the user table. Anonymous has an entry in the user table. So for join purposes, you want that. You almost always want to require the relationship because the two things exist. No comment exists that doesn't really have a parent node, unless it's kind of been deleted. Yeah, you know, I'm not going to make blanket statements, but maybe you're trying to find just orphaned comments. That would be a great reason to left join, not require the relationship. But most of the time you want to, but it's not checked by default, so something where you need a little work there. Ordering by a non-base table, this is kind of slow. Sometimes you have to do it, but if you, for example, query for nodes and then you sort by the number of comments on that node from another table, that's pretty slow. The Drupal core tracker does this, and it kind of has to. I suppose theoretically you could query for the comments and then join the node on that. Theoretically be faster, I guess. But even my monitor slips down here. Using distinct just in case. Distinct is a penalty, and apparently a lot of people go in and they check that box because someday I might have duplicates and I don't want to have duplicates, and so I'm scared, so I just check the box. Only check the box if you have the problem. It's easier said than done when your boss is like, why is it showing 3 times? But don't use distinct just in case. Make sure you really need it. Not using views caching is a huge pitfall. It can cache the query itself, and it can cache the results of the query. And views cache bully is a module that will, I'm not sure if it just harasses you or if it actually just goes in and turns on caching on every single one of your views. But that's sort of a go-to if you want to be aggressive about turning on your views caching, which you should. That's a good module to kind of turn on in dev and see what it harasses you about. Node access is also really slow, and there's no way out of that. It's just, you need to do a lot of joins. Yeah.
So I've heard a lot of recommendations around optimizing joins, things that are going to be slow when you do joins. How much of that is specific to MySQL, and how much is that just welcome to SQL?
I think the bulk of that is SQL. I think my limited experience with Microsoft SQL is similar. Outer joins are slower than inner joins. You always want to inner join when possible. I was always sort of taught that in Microsoft world too. So I think that's fairly global.
So things
Oracle
like
has a comment.
filter by one
so-
table, filter by one table, order by another is going to suck no matter what database you're on.
That's my understanding, though. Of course, the book focuses on Drupal.
Yeah, I can answer that. The problem with the outer join is it implies order. And when you imply order, you restrict which optimizations are possible. Because a query planner, what it does is when you send a query, it's basically the same as a GPS planner. It tries to figure out the best route. But you've said, when you say an outer join, you must take this road. And so fewer choices are possible as a result of that. So other databases will suffer the same way in that they get their optimization list reduced from that.
Okay.
It's not guaranteed that it'll be slower, but there's a good chance that it'll force that order.
The same general guidelines apply to everything.
Yes.
Are these things that you have to know and look for, or are there tools that can say these are where your problems are, you should use with
So some of
building index
the
and things like that?
Percona Toolkit, OpenArc, they'll show you some of that. A lot of what you'll use is the explain statement in MySQL to show how these queries are being built. The first step is obviously, what I want to show here is how to find out, okay, this query is making my site slow. So now what am I going to do? I need to go in and figure out how to optimize that query. So a lot of those other MySQL monitoring tools and using explain is going to help you understand how that query is written.
I'm not quite sure, but maybe Larry could clarify. So is Drupal uses an ORM, right?
Depends if you consider the entity system an ORM. In Drupal 7, kind of maybe sorta. In Drupal 8, I'd say it is.
Okay. So
The
in that
database layer
essence,
is just for the deval. It's not actually an ORM, the DBTNG system.
okay. So in that essence, it's making some assumptions. It's building queries, and so the I guess in one way you don't have to worry about that, but in the other way you might lose some performance optimizations. But so it's like not really something. I don't know. It's like in terms of the bigger scheme of things, it's kind of like more of a niche thing. If you really have some type of problem, that's probably about the last thing you'd probably dive into, I suppose.
Yeah, so I'm not trying, like, what I want to stay away from is sort of the micro optimizations that can kill us, right? And we do this in code a lot. Like, oh man, should I call isSet? And maybe I should call isSet before I check array key exists, because that's a language construct. And sometimes you just should call array key exists, depending on how the actual execution workflow looks. So I don't want to get too deep into it. And there's still like 8 slides, so I'm just going to barrel through. So the actual application itself, Drupal has some settings that are going to help you increase your performance. Go to the admin config performance page and turning stuff on there, awesome. So turning on page caching takes all that work it takes to render that page. You can then save that to a table in your database. So now I only need to read one row out to serve that back. There are even some settings where you don't have to bootstrap Drupal. You can set it so that it just reads that row and spits it back. It's pretty cool. You can tweak them in settings.php. So there's also, you can set expires headers there, which means browsers or edge caches like Varnish or CDNs will cache that content. You can specify those headers right there on the performance screen. Turning on your CSS and JS aggregation and compression is all on that screen. So that's all. Those are all easy wins. Logging, this is one that I didn't know until I read this book, but all of a sudden it's like, yeah, that makes total sense. Drupal comes with 2 ways to write to the watchdog. One writes it to a MySQL table. The other writes it to your operating system's log. So you can sort of offload that effort out of your database and put that at the system level as long as you're able to see it at the system level and get at it. So that's, and then you can use this whole suite of IT tools like Splunk and stuff to parse those logs and understand what's happening there. So, cron also, there's a really good way to run cron, and that is through Drush. So all these pipes in Apache that come in, let's not use one of them to run cron, especially because there's a long-running process that's going to tie that pipe up for a while. Just run it from the operating system through PHP command line. So that's a little pro tip there. Is there a question?
Never mind.
Okay, so basically, writing awesome Drupal code is like cache, 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 load, do less queries. The next one has like 7 bullet points, which is how to write terrible code. So doing the easy thing first, sometimes you just get to a point and you're like, all right, so I need a user, I gotta load this user. Now I need to see if this user can access something. Well, you don't need to do write the access check first, because if you don't care if they can't, you don't need to load the user if they fail the access check. So always make sure you're doing that. Entity API. Entity API provides a little bit of caching down low using like Drupal static, the next guy. And we have now in Drupal 7 entity load multiple. So if you ever find yourself in a loop, and in that loop you call entity load for a collection of 10 nodes, don't do that. This is one of the patches I was able to commit through Core Sprint in RDF just recently, was take it from calling in a loop and make one function that we'll call load multiple, get them out of the database one time with one query. And using Drupal's cache API and using the ability to do static caching with Drupal static is built in there for you. So use those API functions. That's why they're there. Writing awful Drupal code. And I was in Larry's training yesterday where we talked about this first one, which is variable set abuse. So sometimes we have stuff that's not quite config, but I don't really want to shove it in my own table. I just need to store like an array mapping of stuff for my module. So what would we traditionally do? We would just write it to the variables table. I've seen some modules that start doing things that are a little bit hairier, like a variable set user underscore 37, and then a value for that user, because I don't want to write my own table for that. I've seen this. Variable set abuse. Why is this bad? When you variable set something, it invalidates the variables cache. So I've got a site that's serving 400 requests a second. They all come in, and at the same time, and it takes a few seconds to rebuild that cache, all 400 requests now try to build the cache on their request, and you have a cache stampede. So in Drupal 8, we've solved this problem. We've moved all our config out, and we have a key value table in the database where we can actually store this stuff. So that's one way to write abysmal code. Relying on external services, just like that example I told you about. I'm going to go ahead and block this PHP request until this web service comes back, and don't worry, it'll never go down, so who cares? Using the session, stashing stuff in the session. Basically, if a cookie comes into Drupal, then it says, oh, this guy's logged in, and I can't cache anything for him, so I'm going to just bypass cache. So you store stuff in session, and you've just written your way out of using all the great caching that Drupal provides you. Writing finely cached MySQL queries. This is a totally interesting one for me. Let's say you want to show the most recent 5 news articles, but if I'm reading one of those news articles now, then I need a different one. So don't show that one. One of the ways to do this is to say, show me the top 5 where not in, or not mid not equal to the node I'm on. So that's one query that goes and gets cached by MySQL. And now I've got 5 queries for those 5 different pages that I'm on, and really 6 because of the query for when I'm not on that page. Here's what's better. Write the query to just get 6 rows instead of 5, and filter out the one you need on the PHP side. Right? It's a little bit more efficient. But ignoring your PHP warnings. So it's like, well, the code still works, and this warning gets fired 10 times per request, no big deal. Especially if you're logging that to Watchdog in MySQL, killing your Watchdog. And even syslog will get a little hairy here. So committing debug code to production, that's one of my faves. And using development settings in production, like, oh yeah, let's call theme registry rebuild on every page load. Zen lets you just really shoot yourself in the foot with that fast.
Xdebug is another thing that's great on development, but never ever run on production.
Yes, good point. Xdebug, leave it on your mirror machine. Okay. All right, so I did all that. Now what? So a few of the things that we have left. APC. This is almost not an extra thing. This is almost like automatic do this. If you don't have APC installed, just go do it now. The way that PHP works is when the request comes in, we compile it to bytecode, and then we execute the bytecode on the machine. So you can actually take that bytecode, compile it the first time that request comes in, and cache that bytecode. That's what APC does for you. It actually also can act like a key value store. But APC, awesome. Just awesome and a pretty easy setup. So
And unnecessary in 5.5.
yeah, and oh yes, Zend Optimizer Plus comes with PHP 5.5, so if you get to 5.5, you don't need APC because there's an opcode cache built in. I meant to mention that, but I'm concerned about all that. Am I like 40 minutes over? Where am I at here?
You're good.
Good. We were going to go about 15 late, so. Oh, good. Oh, wow, this is going to fit.
You're 3 minutes over at the moment, so you're okay.
All right, perfect. Memcache, so all these cache tables, you ever look at Drupal's DB schema and you see cache, cache underscore menu, cache underscore filter, all these cache tables, these are excellent for getting written to memory instead of disk. Why would I need to read these out of MySQL when I can read them out of memory, which is lightning fast? That's what Memcache is. That's the quick win with Memcache, is it takes these cache tables and puts them in memory for you. Because a lot of these reads are out of cache, especially if you have a site that's mostly anonymous users. Then you can really lean on the cache really hard. Putting it in memory is going to be all the better. APC can do some of this. Redis or Redis? Redis. Did I spell it wrong?
REDIS.
REDIS. So I will fix that before I post the slides. I was saying it kind of more like Redis. Anyway, that's another key value store that can kind of do these things. Memcache seems to be kind of the most used in the Drupal world. It's the one I've heard the most about, but the book mentions them also. Again, book, awesome, get a book. Varnish. Varnish takes this a little bit of a step farther, and it's not exactly an edge cache, but it's a reverse proxy. So what that means is, instead of the request coming in and being serviced by Apache, the request actually gets served by Varnish first. And Varnish can cache your anonymous page